today we're going to look at how to calculate percent yield. So why don't we end up with as much product as we should get? Up till this point, what we've been doing is calculating the theoretical yield. If everything goes the way it should go, how much of this product am I going to end up with? But we know that real life doesn't work out perfectly. So we are going to be calculating theoretical yields, just like we've been doing, and then explain why our experimental yields are often smaller than the theoretical yield, and be able to calculate the percent yield. So percent yield is defined by the actual yield divided by the theoretical yield times 100. The actual yield being how much you actually end up with at the end of your lab. The theoretical yield being the amount that you, in theory, should get if everything went perfect. Just like if you were taking a test, your percent, your grade, would be the actual yield. How many of those problems did you actually get right? How many of those points did you actually earn? Divided by, theoretically, how many could you have gotten if you did everything perfect? And then times 100 just to move the decimal point and put it into percent form. That times 100 is not going to affect your significant figures because that's just what percent means out of 100. The theoretical yield is the mass of a product that you actually calculate doing the stoichiometric conversions that we've been doing. If everything goes perfectly, this is how much we should end up with. So, if you're doing a lab, you have some reactants before the lab, and those reactants are trying to turn into products. Something's going to run out first. That thing that runs out is actually called your limiting reactant. The thing that you have extra of is called the excess reactant. Here it just says the leftover reactants. How much I have left over is not going to affect my percent yield. But I have my reactants, they're turning into products. That's how much, in theory, I should get if I don't lose anything. But we know that particles have to actually hit each other in order to react. It could be that there's a couple atoms left over in the container that just didn't react. Or maybe some of it splashed out of your container or got stuck to your container. All of those things are things that could cause you to lose some of the product that you really should have had. Our goal is to get 100% yield, and the closer to that we get, the better we're doing. To calculate it, I have this question that says I start the following reaction with 40 grams of magnesium and an excess of HNO3. That excess of HNO3 means I have plenty of HNO3 for all of the 40 grams of magnesium to react. If 1.7 grams of H2 is actually produced, what is my percent yield? Alright, this 1.7 grams of hydrogen is my actual yield. That's what I actually get. First, I need to ask to do the calculation to figure out, in theory, how much H2 should I get if all 40 grams of magnesium is used up. Well, 40 grams of magnesium, I need to do my stoichiometry. Since I'm starting with grams, I know I need to put the molar mass in grams on the bottom, and that by definition is the mass of 1 mole. That would tell me how many moles of magnesium I'm using. And then, second conversion factor to get from moles of magnesium to moles of H2. Since I have moles of magnesium in the top, I need moles of magnesium with its coefficient in the bottom. And I'm trying to get to hydrogen, so moles of hydrogen in the top with its coefficient. Since my actual yield is in grams, I want to calculate my theoretical yield in grams. So I need to go from moles of H2 to mass of H2. moles of H2 is on the top, so 1 mole of H2 on the bottom, and the molar mass of H2 on the top. So if we look, I've got grams of magnesium, cancels. Moles of magnesium, cancels. Moles of hydrogen, cancels. And I'm left with units of grams of hydrogen, which is what I'm looking for my theoretical yield. When I plug that into my calculator, I get 3.3176, with a lot of decimals after that, grams of H2. If everything goes perfectly, I should end up with 3.3176, etc., grams of H2. Now, I didn't round to significant figures yet because I'm not done. Calculating the theoretical yield is just the first step to getting the percent yield. You'll remember the formula for percent yield is actual divided by theoretical. Again, the theoretical is what you calculate in your stoichiometry. The actual will be given to you. Or, in some cases, you might be trying to find it if it tells you the percent yield times 100, just to get it into percent form. 1.7 has two significant figures. This 40 grams had two significant figures, which means technically my theoretical has two significant figures, times 100, which ends up being, when you calculate it, 51%. So 51% yield. I'm getting a little over half of what I really should have ended up with. So either something happened and not all of the magnesium reacted, or somehow I wasn't able to capture all of the hydrogen gas. So again, stoichiometry to get to the theoretical yield, and then actual divided by theoretical times 100.